I'm going to go with no. Speak now. Or hold your peace.
My piece is big now.
So, all we're going to do today, just to have some fun and see where some things meet, is do number 5, 6, 7. Everybody can see this, right?
Yep.
Sweet. Yep. So, number 5 is where a cubic and a line meet. And I've had you guys only graph these in your graphing calculator, so it's not like the parabola you would have been able to graph by hand. But the cubic, we would have just used our graphing calculators. But we want to figure out where these guys meet without graphing them. I'll use Desmos at the end to double check ourselves and make sure we got it right. But we got to set these equal to each other, right? That's the easiest way to solve this thing. And I think I made this one that's nice, but what do you guys suggest once you get right here? Ooh, no suggestions. Oh, wait, I gotta go let somebody in. Hang on. Jalen came. Okay, now I'm going back. So, I'll give you this time, but then next time you guys are all over it. This is where you would basically move everything to the same side, because until you can move everything to the same side, you don't have a chance of, factoring it or different things like that. So I always like to leave the biggest thing positive. So I'm going to add the x squared over here. So the x cubed stays positive. And I'm going to minus the 6x minus 6x. And then I'm going to add the 8. So I'm going to get x cubed plus x squared minus 26x plus 24. Is that what you guys get?
Yes. Cool.
Now, I was hoping this was groupable, but sadly, it is not. So honestly, one of the easiest ways to do this one would actually probably be to graph that thing and see where it crosses. But my guess is that it probably crosses like somewhere nice, like, I don't know, like 2 or 3 or something. This is where we gotta use that shortcut box. Do you guys remember this shortcut box?
Somewhat.
It's been a while. I can't actually, did we cover this? I think we covered this at the end of last semester. So that's been a long time ago.
That's a statement I agree with.
Yeah. Yeah, it was last semester. So this is where you kind of do something like this, like 2 times 1 is 2, 1 times 2, or 1 plus 2 is 3. This is 6, negative 20, negative 40. That does not work because we're supposed to get a 0 down there, right? So I'm assuming there is something that works. My guess, maybe 4. Let's try 4. 4, 5. 4 times 5 is 20. Negative 6. Aha! I found it. How's everybody feel about that?
Lovely.
Good job.
Yes. So we would have had to just keep guessing factors of 4 until we found one. So that would have been unfortunate. So I'm glad that we found that one. So this is an answer. What do we do with this to find our other answers? Do you guys remember?
Plug it in.
Plug it into, well, actually, we will come back up and we will plug the 4 in to the original to get the point, right? So I can do that right now. We get negative 16 plus 24 minus 8, which actually, is that 0? Huh. Yeah, I think that's 0. So that is one thing that we'll do. We will make sure, like, whatever x value we get, we got to plug it in. And I think everybody on this call did that well, but I had some people who I think were teaching themselves and they always forgot to plug it in. But this thing right here is still solvable. It's got, you guys remember how if we start with an x cubed up here, right? This is like an x cubed, but this becomes an x squared. And what do you guys think? Isn't this pretty easy to solve?
Yeah.
Yeah.
Yeah, just box it, but without the box.
Hey.
X. And what times what gives you negative 6? That adds to get you 5.
6 and negative 1.
Yeah, I like that. And so then we get x equals negative 6 and x equals 1. And then we got to plug those, just like we did with the 4, we've got to plug those in and get our final answers here. So 4, 0 is one of our answers. Negative 6 comma something is one of our answers, and 1 comma something is one of our answers. So this is saying that this parabola and cubic meet at 3 different spots, which is probably believable, right? The cubic does a little squiggly thing. But let's go back up here and plug them in. So if I plug in 1 seems easier to plug in. That'd be -1 plus 6 minus 8. So that's -3, right? That's that one. Negative, like it's going to be. So plugging it in, squaring it will be 36, but it's -36. And then 6 times -6 is -36 again, and then -8. So -80, I think. We'll see if we're right. So now we have all 3 of these answers is where those go in. And now I'm going to go to Desmos and graph them and see what we get. So I got to finish typing this in though. -20x plus 16. How does everybody feel about that process though, of setting things equal to each other and finding ways to solve them?
Good.
Yeah, so this is just pre-calculus and calculus. You're going to have to get a little bit creative here. So I'm going to come back, and instead of sharing my screen, I'm going to flip the camera.
So you're telling me this isn't creative?
That's, well, creative. You can think math is. So this cubic is like huge. Everybody with me? Like I've got to zoom out, but it does look like there's a point here. Was one of our points 1, -3?
Yep.
Yes.
Okay, that's good news. One of our points was definitely 4, 0. I remember that.
Mm-hmm.
So those 2 are on there. And so then there's apparently one more down here, way down here. Woo! Which, what was it at 80? Is that what we said? So, boom, -680. What do you guys think? Are you convinced?
Yes.
And isn't it so nice to graph things? Like, so we teach you how to do things, but then the graphing calculators have made life a lot easier sometimes, you know? Just gonna throw that out there. All right, let's see about this circle one. It's been a while since I've done one of those. Let's see here. Sharing the screen again. And back to you. Okay. Oh, gotta go let somebody in again. Tell you what. Oh, Ella got kicked off. Never mind. We'll let her back. That's fair. Okay, so number 6 is where a circle and a parabola meet. So kind of just bringing circles back to you. Like this has maybe been a while, but this is one that I could almost maybe graph without Desmos in a second and see if I know kind of what it looks like. Because like I know what a circle looks like. I know it just, this guy moves over to the opposite, right? So it goes over 2 and that's the center. And it's got a radius of 4. So it hits here, 2, 2. Like this circle looks like this, right? And it goes like this. And then we might be able to see where that parabola would go through as well. So actually, I know one spot that these 2 are going to touch is right here. Because this parabola is right there. And it opens to the right. So it could touch more. So this one is actually interesting because I think, if I'm going to be honest, man, I would probably divide by 2. And are you guys good with plugging this into the y? Yeah, that's gross. This one's going to be intense. Let's see what we got. So it's x minus 2 squared plus x squared over 2 squared equals 4. So the first thing I'm going to do is we do have to FOIL this bad boy. Okay. So x times x is x squared, -2x, -2x, and what's -2 times -2?
4.
Thanks. Just making sure you're good. Your math skills are still there. Thanks, Katie. And then the next part, we just can square both. That's one of our exponent properties, right? So it's x to the 4th over 4 equals 4. And then we just got to combine our like terms, which I'm actually going to just minus the 4 from here and here, and they go away. So now we have x squared minus 4x plus x to the 4th over 4. That is nasty. This is something that I don't think you guys have really solved yet. So this is a good one to kind of like see. Like if you have a fraction in there, what I usually do, kind of like what we do with substitution, is I usually multiply everything by 4 just so that the fraction goes away. So we'd have something like this. And then I can put the x to the 4th out front instead. So there we go. So we have that. And then I can pull an x out of this. So I've got x cubed plus 4x minus 16. The question is, this one will be at set equal to 0. We're good with this. This one's x equals 0, and we can plug it back in and we get 0, 0. But actually from my graph, I kind of knew that was happening. So the question is this thing solvable? Well, we could go back to our division box like we did last time and put a 0 in because there's no squares, and try some things. I'm just going to try 1 or 2 because I feel like 1 or 2 is going to be the only thing that really gives it to us. So 1, 1, 1, 1, 5, 5. Well, that's not it. If it's not 2, then I'm thinking that this thing maybe doesn't have nice solutions that we could solve for. 2 times 2 is 4, 8. Ah, there we go. So 2 is another answer. And this thing we could quadratic formula, but I don't know about you guys. If I'm looking up here at this graph and this thing opens this way, and we just said it's probably going to go through at like 2 on the x, my guess is it looks like this. I'm thinking those other 2 answers are imaginary. What do you guys think? Yeah, my guess. Because you do like -2 plus or minus square root of 4 minus 2 times a times, yeah, that's imaginary. So those are imaginary, but we have these 2. And then if you plug 2 back in, here's where it's really interesting to make sure you catch this. Because we got to plug 2 back in, right, to get our points. When you plug 2 back in, let's say we plug 2 back in to the circle one. We could actually do either one, but I think the circle one's the one we want. If we plug 2 back in here, 2 minus 2 is 0, so y squared equals 4. But what happens when you square root 4?
It's 2.
It is 2, but you also need this. Everybody with me?
Right.
Yeah, so that actually means that 2, 2 is an answer, and 2, -2 is an answer because we had to square root that. So boom, actually this and this are all our answers. And my guess is that Desmos is going to show something like that. I mean, that's like super, super good. That is nasty. All right, I'm bringing you guys back here. You guys can see. Ah, sorry. Wait, where's my bait? There it is. Okay. I gotta type these in. X minus 2 squared plus. Did anybody get 1 or 2 of these on their own? Or is this all like new to you?
I was able to do a fair bit of it.
Nice. What is the second equation? Was it 2x equals y squared?
2y equals x squared.
Oh. You know what I missed? My bad. It's only this way. I was confused.
Oh, it's okay.
But we did get 0, 0, and 2, 2. We just had gotten another answer right. We got into -2 because I got it open sideways. Just kidding. And I think it's because you wouldn't have to square root on this one. I bet if it was 2x equals y squared, we would have been right. For my peace of mind, I need to check this out. Sorry, everyone. 2x equals y squared. Aha.
That's right.
Sorry, peeps. So that one would have been there. Good to know. Good to know. All right, last one. Let's do it. A cubic and a line. Do you guys want to predict how many answers do you think a cubic and a line are going to have? Oh, shoot. I keep trying to. Okay, I'm on the wrong screen. Here we go. And we could have any number of things. I honestly think it has to at least have one, because any line is going to intersect a cubic at least once, whereas a parabola just goes. It could have two, I guess, if it touches the tip of something and then goes back down, and then it could have three. I don't think it can have more than three, though. All right, what do you guys suggest? How do we start this one? This is kind of like the first one we did.
Set them equal to each other.
Yeah. So just 3x minus 5 equals this guy. Set them equal and move them all the same side. So unless you got something ugly like a circle, they kind of all follow this pattern. Plus 5, so minus 3x plus 5. So x cubed minus 5x squared minus 8x plus 12. Man, foiled again. I literally was hoping that one of these would be groupable. That's unfortunate. So would you have to guess? Anybody want to guess anything before I guess something? No? I'm going to go with 1. Sorry, just because I can. -4, -4. Oh, yes. I'm so good. First guess.
You cheated.
Boom. I didn't cheat. There's no cheating.
You totally cheated. You cheated.
I haven't seen this since last year.
Okay, fine.
Mm-hmm.
I'll have to believe you.
What do you guys get for this though? Times what gives you -12 that adds to the negative?
-6 and 2.
Nice. So we get 6 and -2. And so those are all our x answers. And then we just plug those back in and get our y answers, which that should be pretty easy. Because we can actually plug them into either equation. The top one is super, super easy, right? If we plug in 1, we get 3 -2. If we plug in 6, we get 18 minus 5 is 13. And if we plug in -2, we get -6. All right, so I have -11. Does that all look right to you guys? Sweet. I apologize. I think you guys are seeing my floor right now. But I will be back to Desmos in a second. So yeah, we'll plug in this last one, and then we're good to go. Unless you guys have any other questions on one from this packet, because this is kind of our last time to address anything from this packet. Then we're moving on to the next packet. You guys need to do me a favor. If you have any freshmen in your lives, you need to help them, because I made the Alg2 packet and the new math teacher made the Alg1 packet. And granted, there's some stuff that's harder in your packet because it's like harder like concepts, but like I told you guys we're doing stat, and there's like some mean, median, and mode and some different things. And like I'm pretty sure that like I made your guys' packet easier than she made the Alpha 1 packet. Like just like the types of, and I'm like, ooh, like my tutoring life for Alg1 in the next couple weeks is going to be the worst. But so if you have any Alg1 friends, like help them out or something. Okay. Here we go. So back to Desmos here. Sorry that it gets like darker and then lighter. So graph both of those, and I think we're feeling good. Was one of our answers at 1, -2?
Yes.
And then 6, 13, I do remember. And then -2, -11.
Correct. Yep.
Yeah, dudes, I'm feeling pretty good.
Woo.
You feeling
Yeah.
good?